Hello, in this video we're going to take a look at section 1 of chapter 7. In section 1 we're going to look at two ways of expressing the steepness of a slope. In Dutch, in deze paragraaf gaan we kijken naar twee manieren om iets te vertellen over de steilheid van een helling. So first, the angle of elevation. In Dutch we call this de hellingshoek. And we're also going to take a look at gradient. In Dutch, hellingsgetal. So when we take a good look at this picture, you see triangle ABC, and over here we see the angle of elevation. It has been measured and written down. Make sure you notice the angle symbol. Angle A is 26 degrees. So the angle of elevation is 26 degrees. You can also calculate the gradient, and that is 12 divided by 25, and the gradient is equal to 0.48. How to calculate the gradient, I will tell you in a few minutes. Because first we're going to take a look at angle of elevation, the hellingshoek. So in this example we're going to take a look at three figures, three slopes, and we're going to measure the angle of elevation because at this point we're not able yet to calculate this angle. So we have to measure, and when you want to measure an angle, you need your geotriangle. So I'm going to show you how we did that because it's a bit of a long time ago. So first, what really is important is this point, and we call this the midpoint of the longest side of your geotriangle. You always place the midpoint on the vertex of the angle. The vertex, het hoekpunt. The vertex is over here. And an angle has two arms. This is one of the arms, and that one is one of the arms. So now I'm going to place my geotriangle, and again the midpoint of the longest side you place exactly on the vertex. Make sure one of the arms is the geotriangle is placed also on one of the arms, and do this really precisely. So when we're going to take a look at the other arm over here, you can see how many degrees the angle over here is. This is what we call an acute angle in Dutch, een scherpe hoek. An acute angle is always between 0 and 90 degrees. So when I start over here, I'm going to count until I reach the other arm. We start counting at 0. 0 degrees, 10 degrees, 20 degrees, and then a bit more. And this is approximately 27 degrees. So the angle of elevation for number 1 is 27 degrees. We go to number 2. Again, over here we see the vertex. Place the midpoint of the longest side exactly on the vertex and make sure also that it's exactly on one of the arms. When you take a look at the other arm, you can see how many degrees this angle must be. And this is also an acute angle, so it must be between 0 and 90 degrees. And start counting over here. 0, 10, 20, 30, 40, and then between 40 and 50. So the angle of elevation for number 2 should be 45 degrees. So the third one, again, we place the midpoint of the longest side on the vertex and on one of the arms. And when you go to the other arm, you can read off how many degrees the angle of elevation for this figure is. Again, start counting by 0, start by 0, 0, 10, 20, and a bit more. And there you see it's also 27 degrees. So we've measured the three angles of elevation. And when you take a good look, you can see the greater the angle, the steeper the slope. In Dutch, hoe groter de hellingshoek, hoe steiler de helling. So this was one of the ways you can tell something about the steepness of a slope. But there was a second way we can do that, and then we use the gradient. Well, this is a really important formula. Gradient, you can calculate gradient by dividing height by distance. So we're going to do this for the three figures again, and be aware those are the same as we saw before. But now we're going to calculate gradient. Height divided by distance. So when we take a look over here, the height is 10 and the distance is 20. So I'm going to use the formula 10 divided by 20, and the gradient for number 1 is 0.5. We do the same for number 2. And then you see the height and the distance are the same. So I use my formula 20 divided by 20, and the gradient is equal to 1. The last one, height 20, distance 40. 20 divided by 40, and we again have a gradient of 0.5. So you see number 1 and number 3 have the same gradient. But also when you take a good look at the gradients, you can tell the greater the gradient, the steeper the slope. In Dutch, hoe groter het hellingsgetal, des te steiler is de helling. So when we do know this, you can ask yourself this question. Does the angle of elevation becomes twice as large as the gradient becomes twice as large? Let us take a look. First, we're going to take a look at the gradient. So we've just calculated the gradients for all these three slopes. And you see, when I just take a look at number 1 and number 2, you see this one was 0.5 and this one was 1. So this one is twice as large. When we looked at the angles of elevation, I used the same figures. And we've measured all the angles. And you see, for number 1 and 2, the gradient becomes twice as large. Does this also happen for the angles? The angles also become twice as large. Is this also times 2? And the answer, of course, is no, because 27 times 2 is not 45, so this doesn't go. So the answer to the question, excuse me, the angle of elevation becomes twice as large as the gradient becomes twice as large, the answer to this question is no. So this is something to remember for the next sections. So last but not least, I'm going to give you an example of an exercise. Look at the picture, and we have an angle of elevation over here. We do know the distance, and I don't know the height. Let us read what we need to do. Calculate the height if the gradient is 0.375 and the distance is 40. So, until now I've given you just only one formula. So that's the only thing I can use, and that is the formula for gradient. Gradient is height divided by distance. So, if we are able to fill in two numbers, I can calculate the last one that's left. So always know your formulas, and when you want to use a formula, start always by filling in everything you know. So I do know the gradient. So instead of gradient, I can write down 0.375 is equal to. So the height must be calculated. So I cannot fill in any number, I just write down height. And then we have to fill in distance. And we do know the distance, it's 40. And again, it's 40. So there's only one thing that we don't know, that's the height. And when you've used your formula, you've filled everything in you know, you can calculate the height. And you can do this like this. You do know this is an equation. And you can do anything with an equation if you do it both on the left side of the equal sign, but also on the right side. And I really want to remove the divide by 40. When you want to remove something, you have to do the opposite. So I'm going to, over here we are dividing by 40. When I want to remove that, I have to do the opposite, and that is times 40. But I have to do this both on the left side of the equal sign and on the right side. When I do this, I will get this 0.375 times 40 is equal to height. Because times 40 divided by 40, those two are opposites. So the divided by 40 is removed now. So the only thing that's left to do is to calculate these numbers. And then when you calculate this, you will find that height is 15. And this is in centimeters, so this must be also centimeters. Do not forget the unit. Yes, always make sure if there is a unit that you take a good look at your answer and make sure you put the unit in the right place. So I do hope this makes a bit of sense. You're going to do some exercises for section 1. Good luck with those exercises and make sure you check and correct everything you've written down.